So this cover lecture 9 and 10. Okay, so once you copy the labs over from the Transforming Lab 5 to your home user, this is what you expect to see the lab data, data CUI, and then you have some scripts, and then you have one main script in the run placement dirt. So this is where I'm at, okay, in my home. So I'm gonna go ahead and take a look at the script. Okay. Um, okay, so first thing you are shown is in terms of the environments. If you don't have environment, just source this CSH Innovis, right? So this not for us. So just fire up Innovis, do the dash log placement.log. This basically dump all the log files here. And then this is just the script here, what it look like. You can open it up and see. So let's go ahead and just source the run placement from your command line. And what this does is this, normally you would you read the DB from floor plan, right? You would just do read DB floor plan DB. But here, since let me go ahead and run this, and I'll show you the reason why we're doing this. Because this design is different from the design that Phil used for floor planning. His design was good for floor planning, a lot of macros. This design is just a block because it has more standard cells and it has a scan change, which is part of what I want to show you guys. You know, the scan chain ordering and things like that. One of a step. So you can see this is different. So um, let me turn on the. Okay, so this is what once you source this, it build basically internally build a design the floor plan and add. Just go to the floor plan step basically. Okay, and it should stop, and it's what you should see. This is the you already know this physical view. Okay, so let's take a look at the row and the side, right? So here I talk about you can do the tickle command. You can cut and paste this and put it here, and it will turn the node up and on right here, just like I just did here. Or this basically just turn the toggle the net on and off, right? Turn off the nets. Or you can actually here underneath here, you can just click it on and off, right? There's a couple ways to do this control panel. Same thing. Okay, so that's how you toggle the net on and off. Okay, to zoom in, I think you guys know to zoom in, just use your mouse, the right mouse, hold it down, just zoom in. You can see the row, right? You can zoom in further, or you can use Z to zoom in, right? And see these, okay. So that's the row, and then you can take a look at the site, the size underneath the row here. So you can turn it's called the row patterns. You can click it. You can see the site, right? All this the same thing. You can execute this command line. Just turn the pattern visible one, then it'll turn it on and off. So that's the site that we talked about, right? So you can play with that. Okay. So once you're done with that, let's run the sanity check, right? One of the thing we call sanity check. So um, run check floor plan is it will check cells are off, rows and things like that. So let's run it. You can hit tab and it's it will finish for you, right? You do a check, you just type here. You didn't know what it is, just hit tab and it'll fill out, say, okay, there's two commands, which one you want? So we're on check floor plan. So you can see you go through check and you have some warning here, say, okay, Halo is not um site, right? So you have to see what's going on. So let's take a look at this and see why complaining about, right? It should ideally you have zero error, but this is a warning, you still want to check. So it want to know this is around this block. So let's go to design browser and find out what cell that is. And then select and zoom to the cell. I'm sorry, select, zoom to this. So it complained about this particular cell, so I put this one. So it's complained about the halo, it's not on the side width. So you can zoom in, you can see the halo. This is the halo, it's not multiple. Basically, it says not multiple the width here, the height of the row. We know, I mean, we know it's okay, so don't care. I mean, it's just block on that portion. It just does check. Okay, so this should be clean. Okay, so let's go on to the next one is check DRC. So we want to make sure that DRC on the PG grid is no spacing rule. There's no violation. We haven't talked about much about the DRC yet. There, you know about the DRV, but not DRC. So DRC basically is called design rule check. So in each of technology, the spacing and the width, and each of the layer there has to be specific minimum width spacing. Okay, if you violate that, the wire too close, it's going to complain. It's going to violate the rules. So let me turn the layer back on. So let me go to the ring and show you. Okay, let me turn off this false antenna violation real quick. Okay, so here you can see the spacing, right? So the DRC, if these are too close, it'll flag because they're minimum requirement on these layers. All the layer has those called DRC. So we check and make sure that these are laid out correctly, because if it's not correctly, it's easier to fix now than versus you go deep down in the flow, right? That later on the flow you have real route, clock nets, and everything, so it's harder to fix. So you want to check and fix these PG issue here. Okay, so no violation, no DSC, so that's good. So let's check the make sure they're no short. One of the things we want to do is check to see short, right? Best is to run this lat. You just cut and paste, some command here, follow the guideline on the lat instruction, and cut and paste or type it in line by line so you can see what's happening. So here, basically, it's no PG shorts. Otherwise, it'll come back. Okay. I review the stream log. Okay, so at this point, remember we're talking about the scan chain, right? The scan chain came from the DFT team, right? They did the scan chain and connect back to back. So here we have a scan depth already. So let's just read it in, and see what happened. There should be like 4 chain in the design. So we read in the scan chain. This is the Leon scan depth, right? So it's okay. It has 4 chain and check it passed. Okay, so that's good. So we have 4 chain. We can't display it now because the design has not been placed yet. So once the design placed, we're going to display the scan chain. Okay, so we loaded telling the tool that okay, the scan chain is in there. Okay, so now blockages. So we talk about blockages, right? Here you have an opportunity to play with it and see the impact of how it works. So okay. So we return in here, basically the universe is stop. It will stop. Okay. So let's add first. Remember, there's three different type of blockages. The first one is the HAR. So let's just zoom in to this area. Okay. Let's turn out the nets. I don't need the nets on. And the row side. Okay. So zoom in. So this is the command to create the blockage here, but you can use the this here, the GUI also, right? This is the GUI. You hold your mouse over, it'll tell you create blockage, placement blockage. Okay. And then you draw the area. Okay. But you can also just do that's the manual way of doing this. Or you can just cut and paste here. You can see it show up. Or you can draw this. The same thing, so it show up also, right? So that's the blockage here. So you see it's a create size placement blockage. So F3, you hit F3. When you hit this, you hit F3, it'll bring up the menu, it'll tell you the percentage, right? Which type, hard or soft. So you want to create soft, you change this and change percentage. So if you do partial, you need percentage, right? So you hit F3. Okay, so it'll tell you shift Y or F3. Okay, so I'm gonna go ahead and so to get out of the adding, just hit select, and then I'm going to delete this extra one. Okay, so let's go on and move and do the editing the partial blockage here. Okay, so two way of doing it, all the same thing. So let me just cut and paste this. And you see this is a partial blockage here. So remember, partial meaning you can have up to 20% in here, in this region, you can place cells in here. So partial blockage, the same thing here, and you hit F3, and it'll bring up the menu and hit partial and change this to 20%. And you click once, and then you drag it, and you left click again, and that's your partial blockage, right? Or you can use the command line. So I'm going to go ahead and delete this one because it's going to impact my density. And the next one is just the soft blockage. So I go ahead and okay, so create. So same thing, you can go through here and select this. This is a GUI way of doing it. Hit F3. Shoot. Okay, I'm gonna hit soft and change this to 60. Same thing, left click on the left mouse and then draw. And notice when you do that, the command is captured here, right? Here, type soft. You can see 60. So that's how you can capture and build a script. So most of the command in Innovus, if you do interactively, it'll capture the ticker script for you, either here or in the command, the log command. Okay, so this is undo. You can hit undo here. Oh, shoot. What does it do? Yeah, so undo, redo. It doesn't do on this one. This actually does on the layout, but not this particular one. Okay, redo, so it undo what I did. Okay. All right, so you can play with that. Okay, we've gone through here.
All right, Doc, we've got a couple of questions that have come in.
Okay.
Let's see. It looks like some students are answering other students, which I absolutely love seeing. The first one is, what are those numbers in the command GUI zoom? It's a rectangle that's been defined. How do you calculate them? I see create blockage, create place blockage command. Are they related? And then a student has answered the first two is the XY, the bottom left point of the rectangle. Last two is the XY of the top right point of the rectangle.
Oh, you're talking about these blockers command here? Yeah, so this is X1. I assume this is a question, right? So this is X1, Y1, X2, Y2. So this is, if you click on this, so for example, here, I click on this here once, then first point, and then click another one, X2, Y2, that would be this one. Does that make, is that one of the questions, right?
Yeah, so I believe that answers the question.
Okay, and then what's the other one? You can do.
Let's see. Just one of our students notes that you can undo when you delete something or when you place a blockage, but you can't undo that place blockage.
Yeah, yeah, this undo, sometimes you can do a few things. It doesn't undo everything. So so this undo and redo, right? So you have to play with it. I can't remember everything on this. So you just have to play with it so we can draw one. I think it can the redo. So you just have to play with it and see what's going on. So I just draw this here and I do undo. So it undo the last one. See, it does undo the one before that. So it does some impact, but kind of funny. See, it should have done undo this one. But on the routes, other thing I know it does because I work with every day. I know on that one. But the placement, I do it once in a while in the placement station only. But so you just have to play with it. Okay. Okay. Any more? Okay, there I answered the question. Okay, so cool. All right. So to zoom out, just hit F, put your cursor here at F, and then zoom out, or you do GUI fit. Same thing, GUI fit. It does the same thing. Okay, so let's take a look at the setting script. This is optimization setting. Okay, remember, okay. This is to set CPU. Okay, so a lot of time, unfortunately, our machine only have one CPU. If you work on a bigger design, if you multi-threaded, you can set the number of CPU that it actually use. So since our CPU is only one, it'll tell you it's only get one. And you can run a command here. See, the number of CPU is two, but actually it's only one. So the lower number will be used. So it's only used one. So here. Yes, so the low you use only one, it's going to use one. So it seems I don't have one. Anyway, that's just a command I put in there so that you guys know if you have a big machine, you can use 64 CPU, whatever, for big jobs. Sorry, it's a little bit slow. Okay, so here all the setting you can see you set the process node so that when you do the RC extraction, it uses the same it use the correct parameters for it. Okay, so I'm gonna source my setting, which we talked about earlier, right? So this is number 9. Okay, let's talk about the help. So let's say we just saw about the offsetting, right? So let's just do a help on something. We're talking about this one, right? So for that, you want to know exactly what's happening there. A lot of command. You do a man timing analysis type. So this is how you find help, right? So you can find more about this single best case, right? Tell you exactly what this is. So this is how if you want to know exactly what's going to happen, and you can do a help and just click it out. And you can do help on a lot of things. So for example, you want to do a help on place, right? You know, start place, you know place. It will list all the things related to place, right? So it lists all these commands, all these attributes, all these variable that you can set, right? Relate to place, right? So you can see all the thing. And you want to know how to set it, do a man on each one of those. So here, place blockers, right? You can do a man on it also, right? Tell you all this. So yeah, so you can do variable help on anything that you want to know. You set. Okay, so oh yeah, so I have example on help create role. You can do that. Don't use cells. So we source a don't use cells. So the next portion of it is so here basically I set don't use command here Excel true one true. So we can do a get live cells. It tabs and just do see if we can actually see any Excel cells in here. Yeah, so this all Excel basically is got a don't use on these. Okay, so don't use. That's what I'm doing. So it's just something that to keep in mind. And then the path group. Okay, so this is exactly what, let's take a look at the path group. Okay, so basically here I'm saying, okay, reset whatever set before, clear it all the options, clear it all, and then just restart, right? Is group path is just a ticker script that you tell us, okay, input basically anything commit to our register and so on, right? So this is actually this should have been into out, into reg. But a black box, basically excluding memories, things like that. And hit this is setting effort, right? You can change this according to. So you sort this one, and if you know that certain path group, normally rest to rest are more important. So internal path important high. But if you know what's what, you can resort, you can update this and resource it and source it again at any stage later on in your flow, right? You set it here for placement, but you can do it again. You can change this optimization effort later on if you know based on your timing summary. If you have a rest problem and you want the tool to spin more rest and turn off everything else, put low on everything else, so the tool work on the rest. Okay, so here you can change it either way. Here I just put congested efforts high. Okay, because I know the timing here is not that challenging, so I'm changing it to effort high. Default is time driven, right? Because I know in pre timing, I know this is not going to be challenged, so I'm going to change it. So you can play with it. Okay, you can play with it, change this to various you see. But I think I have this floor plan here is big, so I don't think it's going to be its design is not that congested or timing critical. Okay. Here I put we haven't talked about module padding. So module padding is in Innovus is a way to tell the tool that, okay, I don't want any tool. So I set 2, which means that I don't want any cell to set next to it, 2 cells away. No, closest 2 cells. So it sees that cell as 2 cells. It makes sense. So I mean it padded 1. So it's trying to spread the cell out. So I have it both. Just to see. You can turn this off and run it and see what it does. You see it kind of clump things together a little bit. Okay. But you add this to 2, 3, it will spread out further. Okay. So you can play with that. So I'm gonna go ahead and set this. Okay. So okay, we talk about this strategy. Yes, so we talk about this. Okay, so now, so when we set all the setting we want, the optimization strategy that we want, okay, all the blockers that we want here. So let's place the design, okay. So this process actually will notice I'm not doing floor plan mode. Floor plan mode, you see the legalized issue, right? But so this placement actually run internally. I run global placements and global routes and everything in there. You see it in the log file. Yeah. So you can see it does all these things inside. So by default, remember it. I mentioned something like Innovus will do a scan chain reordering. If you don't do it, if you want to turn it up and do manual, there's a variable that you can set. I think it's in one of the slides. You can set it, and it will actually don't do scan chain reordering, and then you can do it at the end. It's one of the slides. So what's doing it? Let me see. It's in the other slide, I think. Let me go there. What's doing? Let me go back. DRB. Yeah, here we go. So you can set DB place global reorder false. By default is made true. And then you do place design and you tell it reorder scan. Okay, so you want to do that, refer to slide number 35, and you can do this. Right. So by default, it does it automatically because this variable is set to true. Okay, so let's go. So this is it take a few minutes to do this. So once this is done, we can do a time design. So basically, this will run the RC extractions and it generate a time report inside this DB. I set the DB dirt. I mean inside this report dirt here, which is report directory, I think. Yeah, so I set it to report. So we'll dump it in there. So while it's running, let's take a look at the log file. So it will place. So here's if you do a dash log, I did a placement. So the command, all command to execute is going to be in here. Okay, so a capture in here. So you can go back and build your script, right? So remember here. So whatever we execute or we do it manually in a GUI, then it'll capture it all here in the session, right? So GUI zoom and reference analysis, it capture it all here. Okay, so from here, you can build your script from here by just cut and paste. Build your script. If you don't know, if you know how to do the GUI way, then you can do this in the capture that. So that has the script, and then there's a log, and then log v. Log v basically is for verbose. It means it has a lot more than just a log file. It has timestamp and everything, every command that it ever does, right? It timestamp is more details, right? You can see everything. So usually I don't look at that unless, I mainly look at the log file, this one, because it has pretty much all the things that I look for. So you can go to in. So it's going through iteration right now. You can see. Remember, so the one I highlight in the either the slide or in the lab here, search for it. Those are the keyword, kind of like each of the main steps. You can see, congestion effort here, search for these, and you can see what con effort. And sometimes you want to know what exactly tool is doing. Okay, con effort, right? Hi. So the tool is done, right? So remember, this is the hard blockage. So let's zoom in here. And see the hard blockage, right? The hard blockage mean no cells in there. So let's turn out the blockage.
Yes.
You can see no cells in there, right? No cells. So let's zoom to the other one. Let's zoom out and zoom back in easier. Okay, so let's zoom into this portion. This is a partial blockage. We say on 20%. Okay, so let's click this and turn it off. As you can see, there's less cells in here versus surrounding, so it does obey, right? So let's turn the blockage back on so we can see what the rest of the blockage is. So we have the rest of the other one is sub blockage. Okay, let's zoom out and zoom out. So this is the sub blockage where only buffer and inverters can enter in here, right? So you notice there's none. Can anybody tell me why there's none? There's no cells in here right now. Anybody put in the chat.
Because we
You kind of got cut off. I didn't hear the rest. Okay. Okay, why don't we have buffer inverters yet? Why not? This is not a hard blockage. This is a soft blockage. Right?
I think because we have an run optimization, so it will not push So it will not play a buffer inverter to optimize the design.
That's exactly right. That's correct, because we just placed the design. We have not run optimization yet. That is correct, right? Yeah, you can do you select it, you a queue on it, a query on it, and it'll tell you what it is, right? It's a depth too. So you wonder what that is. That's correct. We have not run optimization yet, so we don't. There's no buffer being placed inside, because this is reserved only for buffer inverters inserted inside. So in the next lab, you run optimization. Let's see, this one does not cover. Did I go to optimization? No. So you see that buffer inverter will get put inside here. Okay. So place details. So it does detail placement. So you can zoom in and you can see the detail placement happen. So there, cells are actually aligned with the row and also should be with the site also. So it does global placement and also the detail placement during place underscore design. You see everything's aligned. So, right. So you can do good idea to do a check place. Okay. So after you cell being added or you just place it, do a check place to see to check that is all the placement to see if there's issue, right? So here, if there's violation, will come back with violation. So it said, okay, you have many cells, form fix. The for fix is the macro, and then unplace is none. Sometimes you have violation something, and then once that happens, we'll figure out what to do. Okay, GUI fit, net, we already went over that. Okay, let's look at the cell. Okay, so the PR boundary, one of the term, you see the cells, right? This is the PR boundary of the cell. So let me show you the left. This is the left view. So in place and route, this is the left view, right? I think she'll talk about the left view, which only contain the PR boundary and then the cell block internal. So let me turn. So for the cell, we want to turn on the pin and the cell blockage. You see the VDD, the power and ground. So you see the power and ground rail here, right? And see, this is the pin A, B, and Y. So it's probably an AND gate or something like that. Let me just go with Q. An AND gate. This is on. You hit summary. This is a mux. Okay, it's a two input mux. So that's the left view. This is a PR boundary. This is internal, right? So that's how you go in and figure out. Take a look at some of these. Yeah, talk about the cell blockage here, right? Your pin, cell blocker turn on and off. So when there's route, you turn on these pin shape, you see that the router actually put the wires on here and put vias on here, my connections. Okay, so yeah, we talk about this VD ground. Okay, cool views. Okay, we went through this different blockage already. Okay, side pattern, Okay, so this is okay. Yeah, the option view. So let's check out the orientation of the cell, right? Let me turn off the pin shape. So remember we talked there was four legal, right? Anybody know what this is? Looking at this, you know what this is? This cells is orientation. Remember there was four. There was R0, MX, MY, and then R180, right? What are this is? So you want to know the orientation, all the attribute to this. This is going to be CR. I think this is going to be an MX. So hit a Q. So to bring up the cell attribute, right? And you can see this is an MX attribute and the status place, right? So there is a whole bunch of other things here that are all the different things in there I don't normally look at. So the summary will pretty much tell you where the cell type, the instant name. So this is cell, this is the instant name. orientation. Okay, so you can go check out the different cells orientation. Here the same. So this is another cells here. You can Q. And then, so this one had R0, right? Remember the lower left slash R0? Okay. So you can have an R0, because this is VD VSS, right? It has a share. So different orientation, the pin may not invalid. So the VD short VSS, short to VSS.
Bach, we have a question that has come in. How can we measure how big the soft blockage for optimization is when we haven't optimized it yet?
Good question. So there are, so normally through experience, right? So you know that the soft block, I mean, I put it here, but normally you wouldn't want to put it in the center here, right? It normally is going to be putting in here. For example, in between these guys. See here, these guys, you see these cells placed in here? This is not good, okay? So right now, this is bad, okay? So normally we put these subblock in the channel, in between the channels where we only reserve it for like, usually there's no cell here, right? Usually there's net go from these long net from these pin that go all the way up to here, right? So they don't get in this channel, sorry. They don't get, so we usually block in between here and we don't put in the middle like this. This is for the purpose of showing you, but this is not where it should be. It's usually in between macros where cells. So this is bad right here. You can see this is bad. Okay. We should have blocked these right here should have been these halos should have been extended larger. So we need to go back. So this is a bad placement. Okay. The reason being is let me turn on the nets. Okay, there is no power. This have got no power to it right now. Okay, this is an oversight on my part on this lab. Okay, there is no power. Let's see, is there power? I don't recall there's power. Let me turn on the okay, so let me turn on the signal nets. Oh, these do have power. Okay. Okay, so these do have power. Okay. But normally we don't allow cells in between like this at all. Normally the halo will extend all the way, or at least we have partial blockage in between, so that so normally we wouldn't want to put it in the middle like the way I have it here. Okay, so for partial blockage, you put them in between where you know you're going to need put buffering layers for fixing DRV or timing on short channel on skinny channel like this on the blockage. You can use Halo if you wanted to. Okay, you can use extend the Halo. It's the same as hard blockage. Halo is a type of hard blockage, basically. So you can extend it all the way out. But if you want to insert, for these channels, you want to insert buffer to fix DRV, you want to put a sub blockage here, because if you have a long net, let's say from this pin all the way up here, and then you need to put a buffer here for fixed DRV or timing, if you put one here, it doesn't do it, then you have to put one here. So that's where you put a sub blockage in, right? So you put a buffer here and it doesn't do it. It's too much cap here or timing. Then you need to put a sub blockage here. But on a other blockage like partial blockage, most of the time on this corner, there tend to be a less routing resource, right? So you want to reduce, or some other area that I have not open and have an L shape, like have another block, just like a small area here, right? You want to reduce the density. Well, if you run the first time and you notice that there's too many cells here and it's show congestion here, right? And then you want to put a partial blockers to reduce density. So it may take a run or two to know how to resolve it. So that's part of the lab. I think it's part of the next lab, how to resolve congestions. Is there is a step where I show you how to do a congestion analysis. So, and then based on that, you know where to go back and accordingly to
And
resolve
so
the
the
congestion.
follow-up question, Bach, is so should we just use hard blockage in the channel between macros, or we just need to use the halo?
It depends. It depends on the channels and depends on the length of the channels too, right? If the channel is small enough, then you probably don't need to because it put a buffer. If the channel is only short to here, and then the buffer will do, then you just block the whole thing off. It really depends on per design. So it's kind of hard to say, but your choice is to put in between channels. If you want nothing to go in there, then put hard blockers. But if you only want to allow, it's a better idea to put soft blockage because sometimes you need a buffering happen, right? To fix the RV optimization. And there's time we block it off, but then later on realize that we need it, then we'll go back and and remove the hard blockers and put soft blockers back in. So there's time it happens. So it takes iterations. It's not just the first time. You know, it'll take iterations of placement. So first time, second time, third time, it may take more than one times. So especially if it's a new design and you don't, it's not a derivative of an older design. If it's a new design, then it'll take iteration to get a good placement. Because when the cell plays, right, the cell plays, it moves very little, right? So it's critical that you figure out all your blockers up front during placement. Yeah, so it's not just a hard rule, put a hard blockage or soft blockage there, right? You can put a soft blockage at the beginning, or you can put a hard blockage depend on the channels and depending on where the pin locates. So this pin right here is way down here, right? So most likely this channel here, I would put a soft blockage here, so I can put so the tool can insert buffers to fix the RV or speed up the path in this channel. Okay, so any more questions? So let's see. Okay, global routes. Okay, let me show the global route. So it's already done global routes, right? So in the global routes, you can go on the grid to turn on the global route. So let me turn up the cells. To turn up all the cells, you can go up here. You see it's the instant, just the visible and selectable. This for selectable, this visible. So turn up the visibility and it'll turn out all the cells and the blockage off too. Let me turn out all the blockages too. Okay, so let's turn on the G cell. Go to grid. No, so this panel grid is down here. So expand, click on plus, expand, and so there's G cell. So this is what happened. So zoom in. Okay, you have to zoom in. So in this case, the G cells, you can measure the G cells here. Really 1.7 by 1.7. So that's a G cell. So you can turn on the G cell, right? So that's a G cell. And you can turn off tracks. Let's look at tracks. On the tracks, you can turn on the tracks. Right? So this is the track. Right? So you can see different tracks going different directions. So this is a 9 layers. I believe this is a 9 layers. Collapse some of these. Layers. So this is the 9 layers. So these are tracks, right? So there's preferred track and non-preferred tracks we talk about. The non-preferred. So the only time I look at track is if the DRC come back and say there are when you have the routes in after the routing, and you're doing check DRC and they report saying that certain some nets are off tracks, and then you can turn on the track and zoom in that, and you see if it's off track or not. So that's really the only time that we use turn on the tracks. But now you know where it is. Okay. So let's turn the cell back on. And turn the net back on and zoom out, see our design. Okay. Okay, so what else we need to show you? Oh, global route, yeah. So you can see these routes look like real routes, right? So you can actually turn it on per layer, I believe. You can turn on per layer. So meta 1, 2, via 2, 3. So you can actually see, let me turn on the sales pin. Actually, sorry, oh, man. Okay, so why don't it show up? Okay, so you can see the router, actually, you can see where the pins have added in, right? So these are, so these look like real routes, but they're not. Okay, these just the global routes. So you select these, the real route will have a fixed attribute, a global. So I still have a ruler. So I'll click on get rid of ruler, select, and you do a Q on it. It'll say it'll say unknown. So that's the global routes. Okay, so real route will have fixed status. So don't get confused. So in the placement, it's not real route, it's just global route. It looks like it's routed, but it isn't. Even the tool says routed down here, but it's not. Even the clock nets. So these are the signal nets, right? So I'll show you how to turn off the clock nets. I mean, this is on the nets. You can turn the signal off and special net off. Special is power and ground, and you see the clock nets left. These are the clock nets, right? These are global route clock nets, but for the purpose of RC, but you can see you can turn off the clock nets here. Okay, talk about that. Okay, scan chain, because I want to show you scan chain, the last thing. So let's turn up all the layers, all the routes. Okay, so the scan chains, remember we talked about it has 4 scan chain, right? So to display the scan chain, go to place. Display, right? That's not scan. This is display scan chain. This should be 4 chain. So we want to do all of them. So you can see 4 different colors. 1, 2, 3, 4, right? So this is the scan chain. This is where it started, where it's in it for the red one. You can zoom in and see. So basically each of those, so you can see each one of these are the flop that it stopped to. So this is the flop right here. See, this should be a flop. You do a Q on it, you should see if it's a flop. So every in and out would be a flop, right? SDFF is a flop. So you can see all the scan. It's happening here. So this one, go to the next one here. So yep. So for this one, there's a lot of flops. So the chain is very long. I think so that it did the best it can, but it looks still a little crowded because there's only a few 4 chain, but a lot of flops. But normally you have a lot more chain than this. But so to clear it, you just go back to place, display, scan chain, and clear. So okay. Oh, to report place density. Yeah, I think this somebody asked before. So the density is already reported in the design timing, but here you can do a check floor plan. And if you don't know what switch it is to do, that's help, right? And it'll say you can do an alpha, just report density. You want to know when it says it, but So at 56%. Okay. Okay, so let's go and generate timing report. We have a few more minutes. So we just done. So we want to take a look at the timing report. Let me quickly generate timing report for this is basically we expected to have timing issue, right? Because we haven't fixed anything. We have not fixed it, we just placed the design. So we expect to have timing issue, right? So this is just going to do the setup timing. So it should come back with timing summary here, and also it place it out in the we told to put in the report directory. The summary just VI the sum is it zip in cheesy, so you need to VI. It should be the same what you see here. The summary should be the same as what you see here. So let me expand it. All right, so as expected, we haven't fixed anything. So our WNS is almost 4 nanosecond, and TNS is 4600. And half of the path in design have violations. And then you see all sort of DRVs, max half, max trend. So so this is the initial timing, place timing here. So it captures what command we use also here. Okay, so if you want to know, so our place red has issue, right? We can go in here and look at the timing path. Remember, yeah. So you can go down. So our timing here, let's look at. So the clocks here, this is it started the clock, right? This is the capture, the launch clock. It goes to the ICG cell and then hit the flop here. So there's no delay until we get to here, right? So here the clock to Q, we get to arrive here is 296 picosecond. So we go to this is clock to Q, this is the capture clock. So when I hit the D pin, the Q pin, traverse to the rest here, it goes through all this logic, right? You can see these delay to this net. So the net delay here show is lump part of this. There is a command to separate the net delay and the set delay, but it lumped into this already. So it's the first one. So it go through a bunch of level logic 1, 2, 3, 4. And then it hit the flop here. So the data arrive time here, just through the logic here, is 7.7 nanosecond, right? So that's what it show up here. Data arrive at the capture clock 7.7. Okay. And then the other EN basically is the capture clock. So the capture clock for that path here, it go through another clock gating. And again, it's because it's pre-CS is ideal, no clock net. So it's, it's arrived at 4 nanosecond as expected, right? There's no delay.
Bach,
So-
we've reached the end of the hour.
Okay.
Wow.
Yes. Yeah. So that was the last part that I wanted to show the everybody. Okay. That's the timing report. So you can likewise, you can go in and look at the rest of these, each of the timing path. Okay. But we know there's timing issue, right? We haven't fixed it. So once we fix it and the timing come back and say, if the timing report say, the summary said that, okay, if it's a meant to reg or issue right here, and we would go into the meant to reg and kind of analyze what's going on. Okay. So that's how you look. So I think we also ran out of time. We reached in the lab. So this is pretty much what I show you guys. So yeah, take your time to go through the labs and play around with it. I kind of show you, capture here, some of the things we talk about. All right, so have fun with the labs, and then we'll see you guys come back next Tuesday, and we'll go through the power analysis and then congestions for the next two session. Okay, that's it. Thank you all.
Thanks, everyone.
The recording has stopped.